Number 7, it says use trig identities to transform the left side of the equation into the right. So remember, with these types of problems, you want to remember the different identities, including, right, sine squared plus cosine squared equals 1, right? Caught a fish, right? Caught one fish or caught a fish. There's also tan in 1 second. Right? So these are like the harder ones to remember. But also remember that like tangent squared theta is the same thing as sine squared theta over cosine squared theta. Secant squared theta is equal to 1 over cosine squared theta, and so forth. Just a reminder, when you do these problems, you're going to keep the sides separate. So don't like balance the equation by adding things to the left-hand side and right-hand side. Keep them separate. Remember that you can replace, you're going to have to replace and simplify a bunch of times, right, using the identities or just simple algebraic simplification. Things like factoring or foiling, adding or combining two fractions into one, or separating a fraction into two fractions are some of the techniques you're going to use. So looking at number 7 here, I'm going to work on the left-hand side and I'm going to FOIL. So when I FOIL this out, I get 1 minus sine squared theta, right? Because these are conjugates, the middle terms cancel out. So I get 1 minus sine squared theta. Well, right, if I look over here, notice that if I subtract sine squared theta from both sides, right, I get cosine squared theta. So 1 minus sine squared theta is equal to cosine squared theta. So I can write that down. Therefore, the left-hand side and the right-hand side now match, so I'm done. So I need to, again, see your work logically flowing to match the left-hand side with the right-hand side. Another thing you could have done here is to replace 1 with sine squared plus cosine squared, and then the sine squareds would have canceled out, giving you cosine squared theta. So oftentimes there's more than one option, but again, you need to show me your work correctly, and I should be able to follow your work in a neat and logical way. On the test, also be ready for me to give you problems where I give you just the left-hand side and I don't tell you what the right-hand side is, and you just have to simplify as much as possible. It may also be multiple choice, so you can kind of choose from the selections that's provided. Looking at number 8, find the value of sine theta given that secant theta is 6 over 5 and tangent theta is less than 0. There's 2 ways to do this. One way is to draw a triangle. Okay, that's, I think, the preferred method for most students. So when you do this, let's think about it. Tangent is negative, so all students take calculus, and tangent is negative in quadrants 2 and 4. And secant, which has to do with cosine, is positive. So of these two quadrants, cosine is only positive in quadrant 4. That means our triangle will be in quadrant 4. Remember, secant is reciprocal of cosine, so it's going to be hypotenuse over adjacent. So hypotenuse is 6, adjacent is 5. You have to use Pythagorean theorem to figure out the y value here. So when I do the Pythagorean theorem, I get that y is equal to plus or minus square root of 11, but since I'm going down, this is going to be negative root 11, right? Because that's positive x, that's positive 5. Hypotenuse is always positive, and then we're going down in the y direction, so it's negative root 11. Therefore, my answer, sine of theta, final answer, will be opposite over hypotenuse. Also, make sure that you're checking your final answer. Like all students take calculus in quadrant 4, sine needs to be negative, so make sure you have that negative there. The other way to do this without drawing a triangle is to use circex or teix, and then also use all students take calculus. So you still have to notice that tangent is negative and secant is positive in quadrant 4. And then you say, okay, well, sine theta in quadrant 4 is negative, so I know my answer is going to be negative, right? And it's going to be so it's y over r. Well, secant, right? Secant is the reciprocal of cosine, so it's going to be r over x. So I know it's going to be r is going to be 6 right here. And then we have to figure out y. Remember, the relationship is x squared plus y squared equals r squared. And if you plug the numbers in, right, y squared equals r squared, you get the same thing of y equaling plus or minus square root of 11. And in this case, right, you could just put a square root of 11, but it's going to be negative y, right? Because your overall value of sine in quadrant 4 is negative. So you get the same answer. Number 9, it says find the trig function of an angle in standard position whose terminal side passes through the point negative 7, 2. So this is one where I definitely recommend that you use, you draw a triangle, or it's kind of similar to number 8. You have to use the idea that x squared plus y squared equals r squared, and you have to use Sir, Kixer, Tykes. These are the ones that you have to be careful. You're not using the unit circle because we don't know that the radius is equal to 1. Remember, the unit circle, right, only applies when the radius is equal to 1. So if you're given an angle measure, you can use that because it's convenient. But if you're given like side lengths, right, chances are it's not, the radius will not be 1 and you will have to find it. So number 9, negative 7, 2, right? Negative 7, 2 would be here. So that's negative 7, 2. Okay, I'm going to draw my right triangle. Again, when you're making your triangle, it's always going to be like in the shape of a bow tie, right? Where theta is going to be right here. Think like reference angle, okay? Note that it's negative 7 in the x direction and positive 2 in the y direction because of the coordinate that was given. So our radius is not going to be 1, right? Because the radius is the hypotenuse, it needs to be greater than both sides. Using the Pythagorean theorem, or x squared plus y squared equals r squared, I find that the radius is square root of 53, and the radius is always positive. So now that I have my x, my y, and my r, I can find the 6 trig functions of the angle. So using Sir, Kixer, Tykes, sine theta is, or you can just use SOHCAHTOA, right? Sine theta is opposite over hypotenuse, 2 over root 53, which is going to become 2 root 53 over 53 when you rationalize. And cosecant theta would be the reciprocal, but it's easier if you just do hypotenuse over opposite, or r over y, right? So you don't have to go through the whole rationalizing process again in this case. Cosine theta is Kixer, so x over r, negative 7 over root 53, which will rationalize to negative 7 root 53 over 53. Secant theta is the reciprocal, so it's root 53 over negative 7. Root 53 over negative 7. Just a quick reminder that this negative could be in the denominator, it can be in the middle, or it can be the numerator. And tangent theta is opposite over adjacent, right, or y over x, that's negative 2 over 7. Cotangent is a reciprocal, so it's negative 7 over 2. Looking at number 10, when you find reference angles, recall that the reference angle is always acute, meaning it's less than 90 degrees, or between 0 and 90 degrees, or between 0 and pi over 2, and it's always positive by definition. So you always want to see what the angle is closest to the x-axis. So for example, if I have 244 degrees, or 244 in the positive direction would be about here, since it's between 180 and 270. And then this is the closest x-axis. So you think, like, how big is that angle, right? So you're really thinking 240 minus 180, which gives you 64 degrees. When you're doing angles like C and D, notice that we are splitting the pi into like fourths, or splitting the pi into sixths. That means no matter which quadrant you're in, right, the little slice is going to be equivalent in size. So I can already tell that for C, reference angle will be pi over 4, and for D, the reference angle will be pi over 6. You could also convert to degrees and then convert back to radians. Another way to do this is to find the coterminal angle, so you can see that in your unit circle, on your unit circle. So if I add 2 pi, right, pi over 4, I get negative pi over 4. And so you can see that negative pi over 4, right, the reference angle will be positive pi over 4. Or if you wanted to add 2 pi again, you would get 7 pi over 4. And then you would see that on your unit circle, right, it would be right here, and you're like, okay, the little missing piece closest to the x-axis is pi over 4. However you need to think about it is fine.